Our entire modern world is built on this silent, invisible giant, the electrical grid. It powers literally everything, but we almost never think about it. Well, today we're pulling back the curtain because this system that we depend on is facing some massive new threats. We're going to dive into its hidden vulnerabilities and the incredible race to secure our future.
We've all had that moment, right? The power flickers, and then it's gone. Everything just stops. And for a little while, it's just an inconvenience. Maybe even kind of fun. You light some candles, find a board game, and just wait for that familiar hum to come back on. But what if the cause isn't just some local storm blowing through? What if the threats are way bigger, way more complex, and coming from places we're not even looking? The truth is, our power grid is up against challenges that it was never, ever designed to handle. So let's really get into this. The power grid isn't just another piece of infrastructure. It's the foundation for everything else. I mean everything. Without it, hospitals go dark, our phones stop working, the entire economy freezes. It is the invisible backbone holding our modern world up. And here is the absolute core of the problem. Our grid is basically a legacy system. As Rohan Kalkar from Schneider Electric puts it, it was designed for a completely different world. One with predictable weather, big central power plants, and energy just flowing one way. It was built for a past that, let's be honest, doesn't exist anymore. And that leads us straight to the first huge threat, our planet's changing climate. The rising global temperatures, the more frequent and intense storms, they're putting this old system under a kind of relentless stress it's never experienced before. This quote just nails it, doesn't it? We are trying to power our hyper-digital 21st century lives on an infrastructure that was designed for an analog era. It simply wasn't built for the climate realities we're all facing right now. You see, extreme heat isn't just uncomfortable for us. It's a direct, physical assault on the grid's hardware. Higher and higher ambient temperatures are attacking the most critical components, especially those huge transformers that are the workhorses of the entire network. And this danger is incredibly specific. If you look at this table, you'll see that the insulation inside these transformers has very strict temperature limits. As these long heat waves push the internal temperature closer and closer to that red line, the insulation breaks down way faster. It basically starts a countdown to failure. It's a real domino effect. The heat makes it harder for the equipment to cool itself down. That means the power lines can't carry as much energy. This strain makes the insulation degrade faster, which leads to more equipment failures and ultimately a much higher chance of major blackouts. But here's the thing. The threats aren't just coming from our own atmosphere. A far more powerful and maybe even more devastating danger is lurking about 93 million miles away. Yeah, I'm talking about space weather. Yep, the danger comes from our very own sun. Every so often, it unleashes these massive eruptions of energy and plasma. They're called coronal mass ejections, or CMEs. And if a really powerful one happens to be aimed right at Earth, the consequences for our grid could be, well, catastrophic. Now, the main weapon a solar storm uses is something called a geomagnetically induced current, or GIC. When that CME slams into Earth's magnetic field, it creates these powerful rogue electrical currents in the ground itself. And our long power lines, they act like giant antennas, just soaking them all up. So here's how it goes down, step by step. The sun has an eruption. That energy hits Earth's magnetic shield and rattles it. This disturbance generates those crazy currents in the ground. And then our grid absorbs all that rogue energy, which can literally melt the copper windings inside those critical transformers, causing a massive blackout. That's exactly what happened in Quebec back in 1989. Okay, so what are the odds of a really big one happening? Research suggests there's a 6 to 12% chance of a massive solar storm. I'm talking on the scale of the 1859 Carrington event that literally set telegraph offices on fire, happening within the next decade. An event like that today could cause trillions in damages and leave parts of the world dark for months or even years. For something that could alter civilization, those are terrifyingly high odds. All right, so with these huge threats coming from both Earth and space, the situation might seem a little hopeless. But it's not. The race to build a resilient grid is already on, and the first line of defense, it isn't concrete and steel. It's data and software. One of the most amazing new tools is the digital twin. The best way to think of it is like a flight simulator for the entire power grid. It's a virtual copy that lets operators throw anything at it, hurricanes, heat waves, even a solar storm, to find the weak spots and figure out how to respond before a real disaster ever hits. And the digital twin is just one part of this whole new predictive toolkit.
Planners are using GIS maps to see which substations are sitting in a flood zone. They're using AI to analyze data and predict which specific transformer is likely to fail before it actually breaks. This is all about designing a grid for the world of tomorrow, not the world of yesterday. In all of this smart modeling, all this data, it tells us how to build the actual physical grid of the future. A system that's designed from the ground up to be smarter, more flexible, and way more resilient. Really, this represents a whole new way of thinking. The old grid was like a tree, very centralized, very vulnerable. You cut the trunk, and all the branches die. The new smart grid, it's more like a spider's web. It's decentralized, it's interconnected. If one strand breaks, power can be rerouted through tons of other paths to keep the whole system alive. And this idea of resilience really comes to life with something called a microgrid. Just think of them as energy lifeboats. A hospital, a university, even a whole neighborhood can just disconnect from the main grid during a blackout and power itself. A perfect example is Princeton University during Hurricane Sandy. Its microgrid kept the campus powered for days while everything around it was dark. So, as we look to the future, the challenge is crystal clear. The threats to our power grid are only getting bigger and more frequent. The race is on, and we have to innovate faster than the risks can multiply.
This is really the central tension of our time, isn't it? On one side, you've got climate change and the wild nature of our sun. On the other side, you have artificial intelligence, digital twins, and decentralized microgrids. Our entire way of life really depends on which side of that race comes out ahead.
Look, the technology and the strategies to build a truly resilient grid, they exist right now. But actually deploying them on a massive scale is a monumental task. So the question we're left with isn't really can we do it? The question is, will we do it in time?